Hello and welcome to the channel. A few of you have requested a video on my project on adding LED lighting to the Honda OEM top box for the NC700 and 750 series motorcycles. So here's just an overview of what I did to add those lights. So this is the Honda OEM top box. It's a 42-liter box. It's actually discontinued, so the newest 2021 NC700X and 750X have a new design for the box, so this is no longer relevant to the latest model, but I ride a 2013 NC700X, and so this is what I have. You'll notice on the OEM box that it has these lenses. These are just clear plastic lenses, and with the stock box there's a silver piece of plastic underneath to make it look like a reflector. It actually looks totally dark. It doesn't reflect any light at night, but it looks like it was really meant to have LED lights in there, so I thought it would be a fun project to just buy some cheap strip lighting and add them in. There are a few kits available online that will add like a single strip of lights to the box. The kit costs 160 bucks. I don't know how quickly it ships, and that was a little bit too expensive for what I wanted, so I decided to make this a project myself. So what you can see what I've done is to actually remove the OEM lenses. There's one screw underneath the strap and then two screws in front that you remove, and the lens will just slide up. I'm not going to remove the lens now because it's already installed. And what I did was buy these LED strip lights off of Amazon. You can get these on eBay or Amazon. They're a little bit more expensive on Amazon, but with the return policy that made it easier to return them in case there was a problem with them. If you look inside the package, what you get is a spool, and on that spool is just a set of surface mount LEDs. I wanted it to be as bright as possible and to have the biggest impact as possible, so I went with these 12 volt 5050/3528 LEDs, and I made sure to get LEDs that had the most elements per meter of strip possible. So these are sometimes called 600 LED, meaning that there's 600 LEDs mounted on a 10-meter strip. There's other names for them, but essentially I got one package in red, which is waterproof, and then another smaller package in yellow. Unfortunately, I couldn't find a waterproof version that had the higher density of LEDs, but the yellow ones are mounted lower down on the lens, so I'm hoping that if there is water, that the top layers will block that. And I've read other people who have done projects similar to this say that they're not very sensitive to moisture. What you can see on the strip is that you have these copper lines, and so what the strip is it's actually 3 LEDs and then a copper mark, and you can cut them to a custom length at those copper marks. Essentially what it is it's 3 LEDs in series, and then each set are all in parallel so that you can cut them and they'll still illuminate. One feature about these Amazon lights is that the lights in some places have already been spliced together, so essentially elements of lights that were dead on the original strip have already been spliced together, and I've read that if you buy the cheaper ones on eBay, sometimes they have dead elements, so you'll have to cut them and solder them together to make them work. Because these lights are 12 volt, I think what you have are basically 3.3 volt LEDs and then a tiny resistor that makes up the additional 1 volt of drop that you need to run them at the correct voltage. But these are dumb lights. They don't have any kind of voltage regulator or anything. And this is different than if you were to buy LED automotive light bulbs on a site like superbrightleds.com. Those light bulbs actually have a voltage regulator built into them, which allow them to run on a vehicle. And the problem is that on like a motorcycle or car with a 12 volt battery, that battery is usually sitting at 11.5 to 12 volts when the vehicle is turned off, and then it can be running up to 14.5 volts when the vehicle is on, actually riding at normal engine RPMs, and that higher voltage is used to charge the battery. And so what you need to do is to compensate for that voltage, otherwise you'll apply too much voltage to these lights and possibly burn them out or shorten their life. So if we look inside the box, what you can see is that I've installed the lights into the lenses and then drilled a very small hole with just a step drill, or sometimes called a unibit, to get the wire through into the box. And I purposely drilled that hole in a place where this little plastic tab covers the hole so that while it's riding, it's water insensitive. Essentially, the wiring is very tight inside of that hole, and it's covered by a piece of plastic when the case is closed, so there should be almost no ingress of water coming in through here. If you're worried about water, or if it starts to leak for some reason, I'll put a dab of silicone caulk on there, and that will solve the problem. And this is drilled just above where these straps hold the luggage in place, so that it's very easy to push this out of the way. It shouldn't interfere with putting a bag or other luggage inside of the case. And here's a really close-up view of my terrible soldering job. So you can see that these strip lights, I used 1, 2, 3 strips of red and then 1 strip of amber for the turn signal. And so you can see the black, which is negative, and red, which is positive for the turn signal wire, and then black and blue jumper wires that jumper the 3 different strips and then go into this hole that I drilled in the corner of the case. And what's really cool about these strip lights is that they line up really perfectly with the ridges in the lens. So when we go outside and look at how the result turned out, you can actually see the individual red dots of the LEDs, and the lens does a really nice job of diffusing that light and making it really highly visible. So it gives a really sharp look. Rather than soldering or using butt splices to attach these wires, I actually added these connectors. So these are Sumitomo HM090 series connectors. You can get them from Eastern Beaver if you live in the US. They ship from Japan. The shipping is very slow and they're a little bit expensive. I picked up a knockoff set from AliExpress, from Alibaba, and I found that this knockoff set is basically equivalent quality to what I ordered from Japan. If you've opened up the left side of your NC700X or the right side cover of your NC700S bike, and accessed that 6P connector, which is used for adding electrical accessories, you may have seen this 6-pin connector. So this is the style of connector that Honda uses for most of the electricals on the bike. They're waterproof, they're really nice connectors, they crimp on really well. They're a little bit big and bulky, so I may replace this in the future with something a little more low profile, but I really wanted this to be easy to put in and take apart until I was sure everything worked, just for testing. And then I just have some wiring from both sides, and then it comes to this voltage regulator controller board. So here's a close-up of the voltage regulator board that I built in order to protect the LED elements from the range of voltages found on the bike. What you see here is basically a wire with a waterproof cable gland that is drilled through this corner of the case, and it actually works out perfectly that this 5-conductor 20-gauge wire outer diameter fits perfectly and tightly into this cable gland, and the outer diameter of this cable gland is just the right amount of clearance so that I can attach the nut on the top of here and it fits underneath the case without rubbing against the side of the case. So that was just sort of lucky that it worked out that way. You can buy these for $5 to $10 on Amazon. They're very inexpensive. But the regulator board, I couldn't find anything off the shelf that really looked like it would work. So I ended up designing and building a custom board for this. So I started out with just like a kit breadboard. So this isn't a custom PCB, it's just sort of a breadboard with regularly spaced holes. That worked out perfectly. That would fit the 20-gauge wire. So I soldered in this 5-conductor cable. So this cable has ground, left and right turn signals, running light, and brake light. So it carries the power from all 3 of the tail lights, both running and brake light, and also the left and right turn signals. And then what the board is very simple actually. It's just a set of voltage regulators. So there's 5 12-volt voltage regulators. I got these on Amazon, but you can also order them from Mauser or any kind of electronic supply store. And all these do is basically take any input voltage above 12.2 volts and regulate it down to 12 volts. So if the bike is running at idle at 12.5 volts, or if the bike is running at full throttle at 14.5 volts, the LED will always see a 12 volt drop across its two terminals. And that way we avoid any risks of the lights burning out or getting too hot while they're running, and it also prevents the lights from getting dim and bright as you rev the throttle, so you get a nice consistent brightness. You don't really have this problem with incandescent lights because over that range of voltages, the light is more or less the same brightness, but LEDs are very, very sensitive to small changes in voltage, so having the voltage just slightly too high means the circuit will draw too much current and burn out the LED, and if the voltage is too low, it'll run very dim. So it's important to have this. And what you see along the top here is essentially a regulator for the left turn signal, a regulator for the running light, and then a regulator for the right turn signal. And then I have these two additional regulators because when I want to run the red lights at full brightness, they actually draw quite a bit of current. And they were going to be drawing a little bit over the rating of 1.5 amps for these voltage regulators. So what I did instead was to have a separate circuit that runs the red lights at full brightness, and each bank of lights gets its own voltage regulator. So the left panel and the right panel red lights get a separate voltage regulator when the brake light is applied. And then there's this little blue dot here, which is actually a trim pot. It's a potentiometer or a variable resistor. And what this let me do is actually use a little screwdriver to dial in how bright I want the red lights to be when they're operating as running lights. And that lets me tune the difference in brightness between running and brake lights to get a good contrast. And it also helps keep the lights run cooler and draw less current when they're just running as running lights. And that way we won't draw too much current through that voltage regulator. And then finally, I just have a pair of diodes so that we don't essentially get current flowing backwards through the circuit from the brake light into the running light circuit. And it makes sure that current running on each bank of lights is running through the appropriate voltage regulator, and we don't have current essentially running in the wrong direction through the circuit. And then finally, there's just a little surface mount button that's a test button that lets me actually test the level of brightness as I'm adjusting that potentiometer. And then you can see I have 3 wires soldered on each side, so these 3 are for the right side of the bike, and these 3 are for the left side of the bike, and those go to these connectors that I made. And then finally, the last part is this set of 3 wires here is actually soldered through the brake light circuit and is running to a brake light flasher module. And this is a really nice module because it's actually, its rate of flashing is based on the rate the bike is decelerating. So when I apply the brakes, if I'm standing still or riding at a constant speed, they won't flash. They just come on as normal. But if I apply the brakes and then hit the brakes really hard and slow down really quickly, the lights will start flashing. And I didn't want really annoying flashing brake lights all of the time. I think that's annoying and doesn't necessarily help safety, but it's awesome to have this module here so that if I have to emergency stop, or if the car in front of me stops really suddenly for some reason, or someone pulls out in front of me, the lights will flash and I don't even have to think about it. And finally, since I'm going to be using the top box to carry my backpack and other luggage, I don't want this circuit to get damaged, especially I don't want these voltage regulators that are sticking up off the board to get bent. So I 3D printed a custom cover to cover the circuit board. So it's really just a basic box. It's 23 millimeters tall, and it's the size of the circuit board. It has cutouts for where the cables solder into the circuit board, and then it has one of the corners clipped off so that it fits in this corner with these 2 pieces of plastic that are used to mount the box onto the rear carrier. So once I get everything set, I'm going to probably glue or screw this circuit board down, and then the cover will just snap right on top, and that will protect it from any luggage that sits inside of the box. I designed this cover using Onshape, which is a free online CAD program. I don't have a background in mechanical engineering or 3D design, but I followed a tutorial, and within an hour or two of working on that, I was able to figure out how to design this. It's printed with PLA plastic, which is a really easy plastic to print on. It's not the most durable plastic. ABS would be a better choice, but for now PLA will work, and if it breaks down or gets wet for some reason, we can always make a new part. It's not a big deal. And here's a view of what the bottom of the case looks like. So you can see this little 5-pin connector. It's a waterproof connector, so there is actually a little rubber gasket here that seals the box, keeps the box waterproof, and there's a little piece of plastic that you can screw on top to cover it up if it's not plugged in or in use. As you can see, it's really low profile. It fits really well along this curved ridge of the box, and honestly I think it looks like very OEM. It looks like it belongs here.
Now that I've gone over how I installed the LED lights, the voltage regulator board, and the cable connector, let's see how this wires up to the bike. The power for the top box lights comes from the same location as the power for the rear tail lights. If you open up the panel inside the inner fender of the rear wheel, there are some connectors that attach the rear brake and turn signal lights. And what I did was to add my connector and my wiring for these lights to that location. So if you pop open the rear seat as if you were going to refuel the bike, you can see that I've installed this wire and the other side of the cable gland with the cable connector. So in order to install the top box and hook up the lights, you simply pull this wire out of the rear seat, close the rear seat, and then this wire actually sticks out right in the location where the rear grab handles are mounted to the frame inside the seat. And this way the wire slides in and out easily and isn't pinched by the seat. You then attach the rear carrier box as normal using the key. And then once the box is attached, you take that wire and you plug it into the 5-pin connector that I've installed. And again, that's a waterproof cable gland, so that is a waterproof connector. Once it's plugged in and screwed on, no water should leak into the sleeve of that cable or into the box. And as you can see here, I'm struggling to line it up because this is all new and I've only had this a couple days. And once that's plugged in, you just screw that cable on to secure it, and you have a really nice, clean-looking cable sticking out of the bike to power the top box lights. And just here's a close-up view of what that cable looks like. And again, the cable comes out right where that rear grab handle attaches, so it's not pinched or damaged in any way. And then it comes up and plugs into that 5-pin connector on the top box. And as you can see, the cable's a little bit scuffed up just from putting it in and out of the rear seat. And here's what it looks like underneath the bike. So rather than cutting or splicing into the existing wiring on the bike, I actually used the OEM style connectors, and these are Sumitomo HC050 connectors. And you can get these from cycleterminal.com or Eastern Beaver. And so you unplug the taillight connectors, you plug my gray cable into the original connectors on the bike, and then there's a basically Y-splitter with additional connectors that you then plug the original wiring back into. And this is great because I'm able to easily remove this cable if I don't want to have the top box light anymore or want to move it over to another bike, and all of the original wiring is intact. I haven't cut or spliced into any of the wiring. And now let's turn the bike on and see what it looks like. In daylight, the lights are fairly dim, but the turn signal lights actually look really nice, and the brake light looks good. And as you can see, both the original OEM brake light underneath the tail and the top box brake light come on at the same time. And you can see that the turn signal lights come on at the same time as well. And here's a better view of the lights at night. As I mentioned before, the strips of the LED lights fit perfectly into the ridges on the lenses of the top box. And so you can see as a result of this, you can actually see every individual dot of the LED lights. And those ridges do a really awesome job of diffusing and spreading out the light to make a nice uniform glow over the entire lens. And so I think this is going to have a really huge impact on safety, and I'm really pleased with the results. I think it turned out even better than I was expecting. And this was a big project, which involved a lot of work, but I definitely think the results have been well worth the effort. Thanks a lot for watching my video and learning a little bit about how I did this lighting, and good luck with your own projects in the future.